All right, this is Mr. Wack. Just going to go through the notes and the assignment with you real quick. This is the 3.4 dilation notes, which is going to be for 11/8, definitely not February 7th. So what is dilation? How is it used? We have a pretty good grasp of what we need dilation for in our day-to-day life. We're used to pinching to zoom and pulling apart and all that kind of stuff on the phone. That's dilation. We are changing the size of what we're looking at, but not the shape. Because we've already studied similar triangles and what it takes to make similar triangles, we already know a little bit about what's going to happen. It's just we're doing some dilation as a transformation of a shape, so we're creating a similar image, okay? So if we play a three-dimensional video game, the images getting smaller or larger are a result of dilation. You're not actually moving forward and backward. It's just that the camera is making parts of it zoom in, zoom out as your character moves so that it looks three-dimensional, okay? The first type of dilation that we're going to talk about, and again, I'm not sure that this is going to show up necessarily on what we're looking at for Delta Math today, but it's still important to look at the different types. This is dilation from a point on the object. So here's my original, and then here's my original with the dilation. You can see point A doesn't move because we dilated centered on point A. This would be if we're doing one without the coordinate plane. So they usually don't ask a lot of math questions about this, but it is something that does exist. You've seen shapes like this before when we were doing similar triangles, so it's nothing new. We move B out to B prime, C out to C prime. We've got something that, in this case, appears to be double the size. So that means our scale factor, our multiplier, is going to be 2. Also, if you remember from similar triangles, these angles at the new places, they don't change. So if you dilate, you don't change the angles. The next one is from a point, there we go. The next one is from a point that is not on the shape. This is going to be the most common you're going to see. So we have point O that's in the center of this triangle, and then we do this dilation. We change all these distances. We know we're multiplying by more than 1 because this is getting larger and not smaller. We have a convergence in the center. If we draw a line from C prime down to C and continue it, it should go through point O. Same thing with A prime and A, B prime and B. The next one that we have here is actually one of the types of dilations that you don't usually think about when you think dilation. Usually when you think dilation, you think it's getting larger. This is getting smaller. So we're decreasing that distance to this point O that is outside the triangle. We're cutting it in half. So we go from B to B prime, A to A prime, C to C prime. And again, if you connect these in a straight line, they should all converge on point O. They're at the center of dilation. Our next one, dilation on the coordinate plane. Anytime we have dilation on the coordinate plane, we're just going to take the coordinates of the point and then multiply them by the scale factor. So if point A is at 4, 3, the scale factor is 2. A prime is going to be 4 times 2 is 8. 3 times 2 is 6. So find the coordinates of the image of each quadrilateral with the given vertices after a dilation at the indicated center with the scale factor. Now, most of your stuff that's going to be on the coordinate plane, it's all going to center at the origin. It is possible to have one that's not centered at the origin. You just have to kind of look for that convergence on your graph, and you can kind of find that point. You should be able to measure sides and give the scale factor if you need to find the scale factor. So with this first one, you would just multiply everything by 2.5. So -2 times 2.5 is -5. 4 times 2.5 is going to be 10. So it would be -5, 10 would be the location of J prime. Down here, I'm not going to go through all of these. Down here we have 3, 4. My scale factor is 1/2. So half of 3 is 1.5. Half of 4 is 2. So this would be 1.52 for A prime. Everything would be smaller. Okay. Your assignment for today is going to be Delta Math. I'm going to go through a couple of these with you just so you can see some examples. So let's pull this up, view assignments. You can see it's on here, it's scheduled. It should show up tomorrow morning by the time you get to class. When we look at the skills here, the first one is dilations of segments and angles. This is funny because I'm not sure why they actually put the angles on here. If you dilate these, you make them bigger, it does not change that angle. That angle's still 145. So do not multiply the angles by anything and hope that you get a lot of angle problems because it's going to be easy. This segment below is dilated by a scale factor of 6 to form this. What is the measure of T prime U prime? When you dilate by a scale factor, you multiply. 9 times 6 is going to be 54. So my new one should be 54 units long. Okay, you do need to be careful because there's the occasional one. Let me see if I can find it. There's one on here, I think, somewhere, and it says that it has been dilated already, and it makes you work backwards. Yes, this. Okay. Wx is dilated by a scale factor of 1/2 to form W prime X prime. W prime X prime measures 23. What's the measure of Wx? So after we multiplied by 1/2, we got 23. So you work that backwards, it should be 46. Okay? So that's that section. Then we have dilation of a point. This one says we're dilating by a scale factor of 2. That means we multiply both of these by 2. -6 times 2 is -12, and 7 times 2 is 14. There we go. So all you have to do on this over and over again is multiply by whatever the scale factor is. You can use the calculator if you really feel like you need it, but most of these you shouldn't. On the third one, the dilations on the coordinate plane, this one can kind of mess with you if you're not used to it. You need to take each coordinate that's on here, dilate by the scale factor. So this point right here is -2, 2. My scale factor is 3. That's going to be -6, 6. Because I'm multiplying both of those by 3. I put my point there. Then my next one is at -2, -1. That's going to be -6, -3. And then my last one here is 3, 0. So that should be 9, 0. Then I have 2 on my sides. I have all 3 of my points. I just need to connect the dots. Once I have connected the dots, I submit my answer. I say, yes, I feel good about it. There it is. And it shows it making the dilation, the transition there. Okay. So if you have questions over this, you probably need to save them until I get back on Monday. Make sure you don't bother the sub too much, and we'll see you when we get back.